All right, so what we want to look at here is numerical data. So we take our survey, we collect all of our information, and what's given to us is all numbers. Through these sections, when we have numerical data, there's 4 things that we want to examine. We want to examine the shape of the data, the center of the data, the spread of the data, and any unusual features. So we're going to start with here is just shape of the data. To examine shape, we need to look at a graph. And there's a few different ways to make graphs of numerical data. So to start with, we're going to look at this data set, and we're going to kind of keep going back to this data set as our example, where we have these 15 exam scores, and we want to see what this will look like, various forms of graphs. The story that we're going to look at is a dot plot. With the dot plot, what we want to do is create a numerical scale along a line. So we have our line right here, and we want to make sure that our number line shows all numbers that fit this range of values here. So I want to be able to see from 30 up to 100. So what I'll do is I'll start off at 30, and then you create some scale. So maybe I'm going to jump by tens and go 40, 50, 60, 70, 80, 90, 100, something like that. So it has to be a consistent scale, so the fact that I jump by tens between each of these tick marks. And then what we do is we start plotting the points, and we plot about where they would be landing. So like 31 might be right there, 62, 65, 70, 76, you just get as close as you can. 81, 82, and then what we'll notice at 82, there's a second value. So with our dot plot, where we plotted a point already at 82, because there's a second one, you stack the dots. So we'd have a second dot there, and then 87, 88, 89, 94, 95, 98, 100. And that's our dot plot. So make a consistent scale along a number line, and then plot the dots above the points, and if they're repeats, you stack them. Dot plots are great for seeing how data behaves kind of on an individual basis, and then you can see where every single little point is plot. However, it's hard to get an idea of trend here. All we can really see is there's a lot over here, and this one's kind of separated. So not so great at showing trend, but great to see how each data point is plot. Next one we want to look at is the stem and leaf plot. The stem and leaf plot separates the data into stems and leaves, and typically the stems are going to be the tens digit. It kind of adjusts based on the size of your data. Like all of our values are in terms of tens and ones places. If they were all in like the thousands or something, we'd want to adjust our stems and leaves. But we're typically going to stick with data that looks kind of like this. So what we want to do is separate our data into tens. So like here's our information for the 30s, 60s, 70s, 80s, 90s, 100s. So you can see we have data all the way from the 30s place to the 100s place. So in terms of our tens digits, we want to start in the 30s and go all the way up until the 100s, which will show us a 10 right here. And what we want to do is write every single stem between those two values. So I want to write 3, 4, 5, 6, 7, 8, 9, 10. So all the way from up to the 100s. So those are our stems. On the right-hand side is where we fill in the leaves, which is the ones place. So like the fact that we have a data value of 31 up here, we want to use that ones place of 1. So we'd write a 1 next to it. So that together that number makes a 31. 40s, we actually don't have any information. Same thing for the 50s. And what you want to be very careful of here is you don't want to write a 0, because then that would mean we have a data value of 40 in our set. You just want to leave it blank to show there's nothing there. Just kind of like how with the dot plot, there's nothing in those bins. But then when we get to the 60s, there's a 62 and a 65. So you just write a comma and list those ones values. We have a 70 and a 76, 81, 82, and then when there's a repeat, you just list it again. 87, 88, 89, 94, 95, 98, and then 100. And that would be our stem and leaf plot. This starts to give us an idea of where values are kind of bundled together. Like we can see that the 80s has most of our information. There's a lot right there, and it kind of decreases away from it, and then that 31 still looks pretty detached with that blank there. So what we want to do is use the stem and leaf plot to make an actual graph, because this just kind of reorganized the data, or the actual numerical values. We want representation. So what we're going to do is create a histogram. There's our data listed again to kind of help us out. I'm just going to write those separators again, because we're going to keep using the separation of the tens values. This data using a bin width of 10. So bin width are just telling you kind of how far to go with the data, meaning grouping with the 30s, 60s, 70s, 80s and such. If we said like bin width of 5s, then we'd have extra separators, like 60 to 65 and then 65 up to 70, something like that. So then these would be separated too. Then we just end up with more possible bins to work with. So what we can do is create a frequency table in order to see how many values are in each of the different bins. So like if we have the 30s, 40s, 50s, 60s, 70s, 80s, 90s, and 100s, next to it we can list the actual frequency, which frequency is just another word for like count. So the fact that we have one value in the 30s, none in the 40s, none in the 50s, 60s we had 2 values, 70s we had 2 values, 80s we had 6 values, 90s we had 100s we had 1. So what we want to do is use these frequencies to help make, it looks like a bar chart. And then we create these bars for each grouping of tens, and the height of the bar is determined by this frequency. So with our histogram, we're going to create an x and y axes like we do in algebra. So we're going to have a y-axis and an x-axis. For the y-axis, this is going to be frequency. So that's going to carry our frequency values, and just something you want to note is you want to be able to see up to 6, which will be able to go 1, 2, 3, 4, 5, 6, 7, so that's perfect to go. And then along the x-axis, that's going to be for our actual data. So like here's where we're actually graphing those exam scores. And we want to be able to see from 30s to 100s. And similar to what we do in algebra, since there's nothing between 0 and 30, we can start our graph at 30 and then use our jumps of tens that we've been doing. So have all of our values. But remember, you always want a consistent scale. So we're jumping by tens here, but then suddenly here we jump by 30. So all you need to do is throw in a little kind of zigzag to say there's nothing in between 0 and 30. We're just skipping over that. Then what we do is create a bar for each bin, in that between 30 and 40 there's one value. Between 40 and 50 there's nothing, 50 and 60 there's nothing. Then between 60 and 70 we have 2 values. 60 to 80 we have 2 values. And then 80 to 90 there were 6 values. So the height of the bar just matches the frequency for within that bin. And then we have 3 values and then 1 value. And notice something that comes through, it's called the right-hand rule. Like if we think of our number line down here, 100 is technically landing edge, between those two bins. But the right-hand rule says that if you land right on the edge, it goes into the right-hand side. So when you have these numbers like 100, or this happened with 70 as well, where on this number line it's landing right there between the two bins, but it always goes into the right-hand bin to give that frequency there. And that's our histogram. We can also make something called a relative frequency histogram, which uses percentages. So we can make a similar table as up above, but instead of frequencies, we use relative frequencies. So we still have our 30s, 40s, 50s, 60s, 70s, 80s, 90s, and 100s. And instead of just counting, now we create a percentage. So like for the 30s, that was 1 out of 15 values. And what we want to do is create a percentage with that fraction. So we take our 1 out of 15, which will give us a percentage of, let's say, 6.67%. 40s will have 0%, 50s will have 0%, 15, and so that'll be a 13.33%. 70s will have the same thing with 2 out of 15. 80s had 6 out of 15, so that'll be a 40%. 90s had 3 out of 15, so that'll be a 20%. And then the 100s had 1 out of 15, which is that 6.67%. So what this is going to do is we'll create a very similar histogram to how we did above. We'll have our y-axis and our x-axis. And our x-axis actually won't change at all. This will still be exam scores, starting at 30, and then going 40, 50, 60, 70, 80, 90, 100. But now what changes is our y-axis. Instead of frequency, now it's relative frequency. So we're going to be graphing here our percentages. So maximum, we want to be able to see up to 40. So maybe I'll do jumps by, let's say, 5s. Let's make this 10%, and 20, 25, 30, 35, 40. Just fits. So between 30 and 40, this will go up to 6.67%. So you just kind of estimate close by. So go up to 13.33, so about right there. 70 to 80 will have the same bar height, so you can just kind of carry that over. 80 to 90 will go up to 40%, so that'll bump up all the way up there. We have this tallest bar. And then 90 to 100 was 20%, so we got there. And then a 6.67% there. And what we can see is the scale is different along the y-axis, but overall the graph is the same. Like here, those have the same frequency. These have the same frequency. Our tallest point is still between 80 and 90. So you get the same graph, it's difference between using percentages and counts. So these histograms are going to be a great way to start seeing shape of the data, because we can really see the groupings here, that this is where the majority of our data is occurring, and then this one's kind of separated away. This graph is going to be called a left skewed graph, in that the tail of the data, I always imagine this as kind of the tail where things trail off. That's going to be where we talk about skew. So our whole point of this is to talk about shape of the graph. So let's talk through the different types of shape. So we can have symmetric data, which if we had a histogram would mean it kind of increases to a single peak and then decreases fairly evenly. Doesn't have to be perfectly even, but should be pretty close by. Skewed left might look something like this, where we have this kind of tail of data, and maybe there's some gaps there, but then we have the majority of our data grouped to the right-hand side. It's kind of like if I follow this data, it's like almost everything's there, but then there's some stuff out here in this left tail. So it's called skewed left, and where you want to think of for the skew is where is the tail. Find the tail, and that'll tell you what type of skew it is. So if it's skewed right, what we'll see is the majority of our data is to the left-hand side, and then this kind of tail is created out here on the right-hand side. So skew is talking about where are these extreme values, or rather these unusual values coming through. We can also talk about mode, which mode is the idea of this highest frequency. It's kind of the peaks of the graph. Like each of these have a single peak, and those would be called unimodal graphs, since they all have a single peak. There could be no mode, which looks like a uniform graph, where pretty much all of the bars are roughly the same height. It doesn't have to be exactly the same height, but should be close to it. Bimodal would look like that there's two peaks. So we'd increase to something, then kind of decrease away, and then increase to something else. And they don't have to have the same height, but it's this idea of increasing, then decreasing out of it, and then carrying that out again. And multimodal would be that this happens more than twice. Something like that, where you have these dips in between the graphs. We're going to talk about next our unusual features, and these are cases we want to be careful of, and no mode as well, in that this shows that there's some kind of hidden groups involved. There's some other trends that are separating the two graphs. We want to see this for our shape. So when we get to describing data and I ask for the shape of the graph, you're going to use one of these three words to describe it.